Good afternoon, and welcome to our session on security challenges in modern application build and development pipeline. I'm Dave Frampton, lead security solutions for Sumo Logic. I'll be joined in the presentation today by Olaf Stein, security solutions architect lead for Sumo Logic as well. And then we have a longtime customer of Sumo, Genesis, that'll be represented by their security lead, Eric Cohen, on stage here. So the goals of this session are to explore at a high level some challenges and some solution approaches to dealing with the new threat surface areas and security considerations that have been generated by rapid evolutions in the methodologies of developing and deploying software. We'll try to give a broad outline up front and then dig into some specific use cases and take a bit of a breadth and depth lens to look at individual systems and how we might approach and think about security use cases, but then also look horizontally across systems and see what security implications there are for how that workflow will evolve. We'll try, for those of you in the audience who are fluent in security, we'll try to hopefully shed some light on some new use cases that you may not have seen before, or some observations on trends as we've looked at the thousands of Sumo customers that have approached these problems. For those of you that are not fluent in security, we'll try to provide a general introduction to the types of security considerations that you need to start thinking about when you start evolving to a very kind of modern, rapid development lifecycle software development methodology. So hopefully we'll balance between the needs of the two groups in the audience. If there's time at the end, we'll do maybe a brief Q&A, or as an alternate, we'll make ourselves available, all three of us, on the side of the room for the last 10 minutes in room if we have time, or if not, out in the hallway. All right, so not meant to be a tutorial on modern build and deployment pipelines, but just to set the table a little bit, what we're thinking about when we say modern application build and pipeline is processes which generally involve continuous integration, continuous deployment, that generally involve a heavy leverage of the cloud, for the cloud, or in the cloud, heavy doses of automation, and generally some amount of shift left DevOps or even DevSecOps, where you're really trying to move upstream some of the operational and security considerations of deploying software. So at a very broad level, that's kind of the environment that we're thinking about when we're trying to articulate the specific security challenges that arise from this type of model. So if we think about the list of issues that come up when you move to this model, the first thing that jumps out is that it's a very distributed model. So we'll go through kind of some of the clusters and ecosystems of tools in the next couple of slides. But in general, you end up with tools which are no longer all consolidated in one place within a secure perimeter. You end up with a very fragmented, distributed tool set, oftentimes hosted in the cloud outside of your domain of security control, and sometimes even outside of your domain of security visibility. As I said, it's outside the perimeter, and you can call the new perimeter the user, you can call it the application, there's probably many things you could call it, but clearly there isn't a well-defined kind of set of security topologies and considerations and models that have been well iterated over time. What you have is a much more fluid and dynamic environment that changes rapidly, new tools evolving, coming in and out, being swapped out. And this provides some serious challenges for security visibility, for monitoring, for access control. In general, you have to think about all the layers of security. Who has access to these tools? How is data sent to and from? What are the security and compliance requirements of data that might reside in some of these tools? And that just gets you to step one. Beyond that, you have to think about how to integrate all these tool sets together in a cohesive and visible defense. Thinking about the modern application structure, thinking about the modular development in microservices, thinking about transient instances as applications get built and then as they go into runtime, and then how in many cases applications chain together calls to other applications in their runtime. All of this creates a whole new set of threat surface areas that you have to think about. And it's no longer kind of the list of well-honed SIM rules that applied to the legacy infrastructure. Now you're sort of in the application layers and the cloud stack layers, thinking about all the different nooks and crannies and opportunities for attackers to get in. It should be obvious that this context that you would collect from all this environment is very diverse, given its nature. But it's also fragmented in the sense that the industry structure is evolving pretty rapidly, so tools are coming in and out. There's sort of there's not sort of the top 3 in each category that you would see in a more mature ecosystem, so there tends to be a good deal of fragmentation that just comes from that churn. Getting all this data together, the policies together, and certainly the sort of correlations and analytics that you would want to do together in one place is a real challenge. In some cases, you have very limited visibility into these tools. In other cases, the type of visibility that you can get is very difficult, to reconcile with some of the other sources and context. So it provides kind of a whole nother sort of data grooming challenge from a security perspective. Oftentimes, these sorts of pipelines are generally applied to production use cases where an application is going to be internet-facing and maybe in a way that it previously wasn't. With digital transformation, as people sort of move from legacy models of delivery and sharing and collaboration. And this just leads to an explosion in the amount of machine data that's created by all of these applications in their runtime. And so there's just an already overstrapped security data avalanche challenge that gets made even doubly worse as you start migrating more and more to these type of models. And then finally, we alluded to up front, there's a big trend in trying to shift some of the security considerations upstream as the applications are developed, in terms of analyzing the code, in terms of instrumenting the code, in terms of checklisting upstream components that are used in the code, and so on. And all of this has combined with the DevOps trend to just increase the cycle time pretty rapidly for how often these applications are updated and then released. Ideally even down to weeks and days as opposed to the old kind of months and quarters. So all of these things take an already pretty challenging security problem and add some significant complexity to it. So double-clicking a little bit on the ecosystem of the tools that are typically involved in this, I mean, if you just look at, okay, we're going to build, deploy, and then run, you can break down in each of those categories. There are 3 or 4 subcategories, and there are whole ecosystems of tools that participate in each of those. You can easily get, dozens of tools, some of which are provided by, relatively new companies, right, which may not have the maturity of logging and the maturity of access control that you might expect, from more mature offers. So this tool sprawl provides a significant challenge. Certainly, you're Noah's Arking in a lot of these categories, so you're not going to have every vendor on this list, but you're going to end up picking from each of these buckets, and by the time you're finished, you're going to end up with an entire list of tools that maybe 5 years ago you didn't have to worry about from a security perspective. And the last piece of the challenge is the people and the process aspect of it. I mean, the technology and the tools always gets a lot of attention, as it should. It's area of most change and dramatic impact. But the people and process changes that accompany this new way of developing and deploying software are fairly significant. There's a way to think about it is on the left part of the screen, there are roles that are typically involved in the workflow. And on the right side, there are tasks or functions that they do. And there's just much more of a many-to-many mapping in these type of processes. Everybody does a little bit of security. Everybody does a little bit of operations. Each of the functions on the right oftentimes involves several different roles on the left, and so on, and all the combinations of that. So this has some implications. I mean, you end up with a lot of layer 8 considerations, the differences in organizational maturity and skill levels and processes across these different groups. All of that has to be taken into consideration as you try to put in place a security posture and a way to update security across these workflows and the organization. So admiring the problem thus, so we've talked about sort of three components, of it. And, if we look out at our customer base and how they're approaching this migration, and the vast majority of Sumo's customers are at some stage in this migration, many pretty forward-leaning in it, who do this, in and for the cloud. We see some patterns emerging in the way that they're approaching the problem, or the ways that seem to be effective, looking across multiple customers. And so sort of close with this piece before we hand off to Olaf to talk more concretely about some very specific use cases in each of these areas. But quickly, the first one is probably the most significant, and that's the democratization of security. Not just the analytics, but also the workflow and the shared data underneath it. Typically in modern security workflows, there's essential participation, whether it's providing context that no one else has, whether it's providing access to a tool or data that the traditional SOC can't. In general, there's much more of a zigzagged workflow across all the different aspects of IT, not just a group of kind of vertically siloed security people, or even people just working inside of an isolated SOC. And that turns out to be absolutely essential in dealing with some of these workflows. These use cases are just not even solvable. I mean, to investigate a threat, to prioritize a threat, to determine if something is a false positive, to figure out a correlation rule, there's just no way that three people sitting in a siloed SOC are actually going to figure that out at any pace that makes sense. So first big sort of true north is democratization of security. And that's broader than just this upstream code analysis and testing. This is the entire sort of security function, including a lot of the things that the SOC has done previously. The second piece is the need to bring most of the emphasis and visibility and monitoring off of the infrastructure layer, where it's largely been. Many people estimate about 90% of their security attention is directed at the infrastructure layer, but they observe, they feel like most of their risk is actually in the application and cloud stacks now. This is where the attackers are going. A lot of that infrastructure risk has been kind of pooled and shared by providers like AWS, and so the attackers are now going into the surface areas that are up the stack. And it's really clear that a lot of the traditional security tools and policies and procedures have to be recast in that light, to go up that stack as well, to be able to have equal effectiveness. The third component is the need to accelerate the workflow. I mean, a lot of this is all about automation, and certainly you should automate wherever you can. And there's a good deal that you still can't automate. And as you move to these modern application, build and deployment models, the volume of data, goes higher, and then your time to analyze it and react goes lower, and that's already against a pretty difficult problem of keeping up with that balance in the old model. So there's really a call to innovate in those workflows that you can't yet automate. How to make people and machines come to conclusion, much more rapidly than they can, with current generation tools. And we see a lot of productive experimentation. We see innovations in technology. We see innovations in workflow, innovations in how people manage skill sets within their organization, to really try to get, at the pace that's going to keep up with the velocity that these apps are developed and deployed. The last piece is a little bit of a newer trend. This is the sort of need to connect the very upstream application security that's concerned with inspecting code for vulnerabilities, and checking, upstream contributing components and instrumentation within the code. All of those upstream functions typically are ships in the night with the downstream functions of the security operations teams that are actually monitoring the applications as they're deployed, in runtime in the wild, to see if they've been compromised or attacked, right? And what obviously, the ideal system is where you would have a closed loop, where those teams would not only collaborate, but you would automate in some ways the things that you're worried about as vulnerabilities in the application as it's built, then get driven all the way downstream into the methodologies for how the applications are monitored, the analytics that are done on them to see if there's potentially an indicator of compromise or they're a threat. So we see, it's definitely a daunting and challenging problem, but we see a lot of productive innovation, within our customer base looking at this. And at this point, I'll ask Olaf to come up and click down one level and talk through some use cases, both the depth of these individual categories of systems, but also the breadth of how we connect the dots across them.
Yeah, thanks, Dave. So I want to talk a little bit about the challenges when talking about monitoring some of the activity on the build pipeline. And I'm specifically talking about the tools and the infrastructure that you guys are using, and not so much like the hardening of the infrastructure or general application security. So when you look at this rather simplified slide here, right, a lot simpler than what Dave showed earlier, one thing that pops up, and he already mentioned the word fragmentation, right? What we see is fragmentation in basically two different places. On a technical level, you have all these tools, lots of them you're consuming as a service, right? Some of it you may host yourself, either in your own data centers or in AWS, for example. But at the end of the day, all these different tools that do all these different things, in order for you to push your application out to production at the end of the day, each of them can be thought of as their own perimeter, as their own threat surface, because they exist in isolation of all the other stuff that you have very often. Adding complexity to this is that these tools can be used in many different ways by you. Also adding complexity is the way they interact with each other, a lot of different permutations and options there. And then, and Dave already alluded to this as well, these tools change at a very rapid pace. So it's not that you have the same set of tools for a long amount of time. And then there's organizational fragmentation. These tools may have different owners and operators. This may be different teams. It's not always going to be the same team. And at the end of the day, a lot of the contextual knowledge about how these tools are used resides within those teams that own and operate these tools, and your traditional security operation may not have enough of that context to actually make good decisions based on what they see in terms of activity on those tools. So that's on an individual tool level or infrastructure. I group that in there. Of course, these tools don't exist in a silo, right? Ultimately, all of this exists within some corporate setting. There's other tools or other assets from a corporate perspective or from a security perspective that ultimately play a role in all of this as well. They may not be directly tied to the application you're building, but all of this exists in a larger corporate ecosystem, and that has to be taken into account from a monitoring perspective here as well. So before we go into some concepts and use cases, I want to talk real quick about risk here for those of us or of you that are not necessarily living and breathing security every day. Of course, there's many risks of your infrastructure being compromised, sort of in order of how bad it is. If you start leaking, data from your customers, as an example, and the public apology that follows thereafter, that's of course something everybody wants to avoid. You could potentially be losing intellectual property, be it in the form of source code or any other form. Your infrastructure could be used for unintended purposes, right? This may not be something that becomes totally public, but that's of course something that you want to keep in mind. You may get in trouble with your auditors if some of these things happen in your environment. And at the very least, if an attacker finds a nice landing spot inside your environment, it's going to make it easier potentially to expand from there than having to come in from the outside. So, what are some of the things that we see people looking at on their individual tools and on their infrastructure? On a very high level, You could start looking at things like anomalous behavior by users or access keys, right? Is a user doing something for the first time? Or is he, as an example, right? We could look at anomalous behavior by origin. This could be as simple as you detecting activity on your AWS account from outside of the US. If you don't have any users outside of the US, that may be a concern or something worth looking into. Of course, if you are a global organization with a distributed workforce, this can become much more nuanced than that, but that's just a simple example. Same thing with timing. Oftentimes, we can do analysis, especially with levels of automation like we have them today. There's fairly predictable patterns oftentimes, and we can leverage those patterns to detect things that fall outside of them. This could be as simple as the old after hours activity. I'm taking this further. Anything that happens outside of deployment windows or automation schedules may be worth looking at. And then, of course, the same old activity from known bad actors. If you're seeing any activity from, say, IP addresses that are known bad, then that is probably something worth investigating further and potentially blocking. From an organizational perspective, this is where the tricky part comes in. Who should be doing all of this, right? Historically, there was a security team or a SOC that would do a lot of this monitoring. I think nowadays we're seeing a shift into this responsibility, moving back into the teams that own and operate these tools, be it an IT team, a DevOps team, or anything of that nature. And the main reason for that is, again, it's all about context. A corporate security function may not have, or probably does not have, the contextual knowledge to interpret the data that these systems spit out and properly, without either causing way too many false positives or missing things because of lack of context. So outside of general indicators, there's also a few other things that we typically recommend looking for more from a housekeeping perspective. So these are not necessarily items that immediately raise a red flag, but they are worth keeping an eye on in general, as well as from a baselining perspective. There's some good information here to provide additional context. We group these into 4 different sort of high-level events. The first one is around authentication, right? I want to have a handle on who is authenticating to my systems. If nothing else, I can potentially clean up users that haven't logged in a while, or I can recycle older credentials, right? Just housekeeping items from that perspective. A privileged activity. That's a second big topic. This is not as simple as it used to be, where you would just look for root activity on a Linux box, right? It's a lot more nuanced nowadays. But oftentimes it still makes sense to put in the thought about seeing, what users have access to what data or to which systems, for example, and keep a closer eye, on your crown jewels versus some lower, like sandbox environment or whatnot. Account management events, right? What users, groups, policies, whatever it may be, is being created, something that you ultimately probably want to keep an eye on in general. And then last but not least, system and configuration changes. Anything that affects the security of your systems and or the operational viability, I guess, is something that's worth looking at. This could be as simple as finding security groups that are being created that permit more than they should, or somebody turns off logging on your CloudTrail, right? All things that you would want to know about and you would want to look for. Same here as before. This probably is mostly a task for somebody who has all the context, who uses these tools every day, who can interpret the information that or the findings the proper way. All of that said, we still see a reason for a more traditional, like corporate security team or a SOC to actually exist. Because ultimately somebody has to look at all of this stuff holistically across the board, right? Ultimately, we want to put one and one together. What may be considered barely noise on an individual system. If you put it together with activity from other systems, it may turn into a signal rather quickly, right? So two yellows make a red, or don't necessarily make a red, I guess. So for example, if you're just seeing a heightened amount of failed authentication activity, on an individual tool, you probably wouldn't worry about it too much. But if you're seeing it across your tools and the volume gets larger, and you can correlate these events, either by timing or by where they originated from, and you can sort of tie them together by that, then that may be something worth looking into. It may just mean that somebody's trying harder than usual to get in, right? And you can take the proper measures to block such activity from there, for example. We also like to look at sequences. Everything is automated, right? Everything has patterns, like I already said. If we find things that happen, out of order, in which they normally occur, or things that happen without the events that normally precede and follow them, then that is something worth looking into. Could be an operational issue, but still better safe than sorry at the end of the day. So those are just some other examples. And then, of course, if you look at the build pipeline by itself, we would want to look at that. But as I said, this doesn't normally exist in a silo. So whatever other corporate tools you have, you want to take those into the equation. And this, again, falls more on the corporate security team or SOC. This could be any security tools, scanners, or whatever you're doing, code inspection, as Dave mentioned. But it could also be looking at your O365 or Salesforce logs or your perimeter firewalls, right? An attacker is not going to just pick one spot and try to come in there. They're going to, if they really try, you're going to see signals across multiple tools. And ultimately, it needs to be somebody's responsibility to put all of that back together, because individually, not all of them may be considered a signal. So again, the who and the how, this falls back on your more traditional security team or SOC. And now I'm going to pass it on to Eric.
Thank you. I hit the right button, good. So at Genesis, we do everything with DevSecOps. Everything is automated that we can. We're still automating. Our goal is to automate ourselves out of a job in security. We hope to get there. So just to get an idea of where we've come from, when I started with what became this particular company, we were a startup, and I think I was employee number 34 or 35. To give you an idea where we're at now, we're at, I think, 7,021 EC2 instances. We've gotten a little big. 200 microservices. We're totally NOC-less, we're SOC-less, and we run an immutable infrastructure. So everything in production is unchanged in production. We make 0 changes. If anything has to be fixed because something is broken, we fix it in development and we push the change out to production. The only thing that we can do in production is troubleshooting to find out what the issue might be. Otherwise, that's it. There can be no other change. There can be no changes in production, not even a security group rule. Everything is done by code and is done starting in development, pushed back up to production. We're partnered with our developers and with our DevOps. So our security team, it's not large. We have 4 security operations on call. Run all of this, and we're able to do that because we're partners with our developers and with our DevOps. Things don't sit around very much. As you can tell, we do a lot of deployments every week, and the number down at the end is our deployments to production. So that's a lot of deployments to production. One of the reasons that's so high is that we don't patch anything. People look shocked, especially auditors, when you say, oh, we don't patch anything. And that's a great way to get an auditor's attention, is tell them you don't patch anything and you're in security. But the real answer is we don't patch anything in production, because that is an immutable environment. What we do is, between us and DevOps, is there is a new base AMI produced every couple of weeks, and the rule is everything in production has to be replaced within 30 days, so it can't be more than 30 days old. So everything in production is rebuilt on new base AMIs that are less than 30 days old. So that gives us a couple of things. One, we have a patched environment, so we're meeting our compliance requirements for PCI, HIPAA, all those different requirements that we live for, in compliance. The other thing it gives us is, and those who are in security know this, if you patch a server and someone's already compromised it, most likely they're going to retain the foothold that they had. They used whatever vulnerability was on there to get on the server, put their foothold in place, and now you've gone ahead behind them and patched it. That hole is gone, but they've already put their foothold in. They maintain their hold. And there are literally, places I know of in the past that patch servers, and people have had footholds on them for a couple of years, even though the servers are fully patched. In this situation, that can't occur, because that instance is literally destroyed after load balancing to a new instance. So they've lost that. This is our basic start of our build pipeline. We're going to build on this slide just a little bit, but you go from your repo. You can use any repo you want, really. And in our case, we have this base AMI, and we're using Amazon Linux. And we've taken the Amazon Linux. It's got the basic services that we need on it. DevOps has put the tools that they need in an Ansible playbook that runs on it. Security's put the tools they need on it. So we have, we're using Threat Stack, and we've got some other tools that we've put on it. And we've gotten a little fancy with our Ansible playbook so that everything is done by region. We're in that 5 AWS regions, so everything knows what environment it's in, whether it's development, production, test, and it knows what, whether it's in Ireland or Sydney or Japan. And everything's configured correctly based on the playbook. And then the devs build their services with their playbooks that launch on that base. Then they build it, it goes in development, they get to start working on it. Everything's great. We don't have to worry if a developer who's building a new service remembers to add our tools to it. So in security, we're not sitting there saying, oh, did they remember to put security tools on it? They don't have to. They're building off the base AMI. We know they've got the latest patches. We know they're using the right version of Linux. And they've got all the DevOps and security tools. So here we're expanding it out a little bit more. And we're looking at our security workflow. So it's now been created, and we've got looks like a scanning process in here. And that's exactly what it is. When the devs kick off their build, so they've built their service AMI on top of the base AMI, and it launches and produces a service AMI into development. And the developers can start doing their testing to make sure it works like they want it to. Well, at the same time, CloudWatch is going to give off an event that says, hey, a new AMI is just launched. Well, we're polling for that topic to come up, and we're going to launch a clone of that instance on a spot instance, so it's cheap. And we're going to run AWS Inspector against it so that we can do a security scan of the instance that they just built. And we're going to publish that into a centralized reporting that our DevOps team built. And this centralized reporting is really cool because it's got everything about that service AMI in it. So it has, all the Jira tickets, the Jenkins jobs. It's got everything about the life of that service AMI in a centralized console that everybody can get to. So the scan results are now there. The security team can see it. What's more important, the developers can see it. So as soon as they built the first time that they've built their service, not only do they get to start looking at their service to see if it does what they want, they get to see, oh, I may have these issues that I need to fix. Long before it comes to security and we say, hey guys, you got some issues here. They have that power themselves. They can already look at that and say, okay, I may have something to fix here. We originally wrote that with Nessus, as a matter of fact, and then Amazon came out with AWS Inspector, so we were able to migrate that over to Inspector. Now that same orchestration tool actually works across our accounts. So we happen to use a different account for development, test, production. And this tool works across all the accounts. So the developer will kick off the deploy. It may fail, it may be successful. There's a lot of reasons for that, and we could spend a lot of time going over the logic on why something fails or doesn't fail. What's a successful deploy, what meets the gate, what doesn't meet the gate. There's a lot of scenarios. But assuming it deploys, it's going to go through integration testing, which is a set of QA tests that were already built, and it goes through all the QA testing. We've got our security test that's going to go in there, and then they can be promoted. We can promote them to test. And they can go in the testing environment for additional testing. Now, here we can say, oh, you can go right to prod. And all the compliance people in the room are going to go, wait a minute, you can't go right to prod, which is an excellent point. You can't go right to prod, and that's going to be in the next slide. So here's a little more about how it actually works. So we're going through our pass-fail. Let's say we pass. We're doing our security audit tools. We're gathering all the information about the reporting, and that's all being stored in a central location. It's getting all the integration testing. Everything's looking good. And the developers want this to go to production. The part we were missing was change management. Everybody's got to deal with change management. So here, in the centralized reporting, we automated change management as well. I'm taking the broad we because DevOps did this, security didn't. So what they put into this centralized reporting was a simple click. The developer can click, I want to push this to production. It generates a change management ticket, which is in the Jira workflow. The change management ticket is populated with everything they need to know, or the change approvers need to know. Here's the applicable Jira tickets, here's the Jenkins job, showing the integration testing, here's the security testing that was done, everything that's needed to know for the change to be approved. And this is really the only point now where a human is still required. So at this point, a human has to come in and actually go, okay, the change is approved. And then it can go to production. And we're actually working on automating that. So we're working now to figure out a way to automate that and still be compliant, still have a PCI auditor or a SOC 2 auditor say, yeah, okay, that still works and meets the change management requirements. But we're working on that one. So we've talked about our build pipeline. And a lot of this talk is about monitoring. We do a lot of monitoring, and you would think that we would get some monitoring fatigue because there's only 4 people in the security operations. We really don't. So we're monitoring for a lot of things, and you can see here, we're looking at, is anybody trying to log in with root? And that's root for both AWS root in the console or for root login on an EC2 instance. Both of those things are going to raise a canary. We want to know about it. It's going to raise a page. Open security groups. That's a big one. And we've gotten very granular with Sumo Logic to specify exactly what we expect in security groups, what are allowed, and what, and outside of those bounds, we're going to get an alert. Failed AWS login attempts. This is all CloudTrail again. You can We can filter for it in Sumo and get alerts based on it. We have dashboards built for our instance age. Remember we talked about we don't allow instances over 30 days. We need a way to track that. So we've got that set up with dashboards. We're also tracking our S3 bucket permissions. So there's a lot that we have set up in addition to these that just allow us to use automation and granular reporting to let us know the things that we want to know without burning out our team with audit fatigue. There's two sides to that coin is then you worry about, okay, well, what if somebody's doing something really low and slow so they can get past your whatever they figured out your audit thresholds are. So we manually review also. So every day we're going through and we're doing that look of what looks odd, what's a pattern that we're seeing in a manual review of our logs. So we have our automated and we have our manual review of logs that helps us, one, avoid the fatigue of alerts all the time, but also to look for those things that stand out. Oops, did I go backwards? Oh, here it is. No, I didn't. This is another alert with another tool. Now, this is looking at the EC2 instance itself. Again, this is an immutable architecture. We don't expect certain commands to happen in an immutable architecture, especially, this is looking at Linux because we're entirely Linux-based. These commands normally will not be seen in this architecture. So if somebody malicious gets onto your box, the first thing they're going to want to do is, who am I to see, do I have root? Or what level do I have? And there's other commands. There's a lot more than I've got listed here, but there's a lot of commands they're going to do that shouldn't happen in a production environment. There are also times when those commands are used in troubleshooting. So you will see a curl because somebody needed to get a log. Any one of those will trigger a page alert. So that will page a security engineer. And you'd think that would cause us a lot of alert fatigue, but it doesn't because our developers and DevOps are really used to the fact that if they do something like that, they'll get a call from us immediately. So they're really good about saying to us, hey, I'm going to get on this box. I need to do X before they do it. And they'll let us know what's going on. Because if not, they know that security engineer is going to get paged at 2 in the morning and call them up and say, hey, what's going on? That's what we have to do to make sure that it's not malicious. So we talk about, the kinds of things we look at. We look at, it's a real, I think someone mentioned depth and breadth before, and it really is. We look at a wide range of things. So this is just one dashboard that also alerts if you hit the thresholds that is looking at Dirbuster. Someone's running Dirbuster against our public-facing servers. We have a lot of these set up for different things that you would encounter on a public-facing server. Spikes like this, there's a certain amount of traffic you would expect, and then there's traffic that goes over a threshold, and these are thresholds that you'll see, or that we'll see that show us, hey, someone's doing a recon attack on us. We have 3 levels of notifications. So we have a page alert. Something's happening that one of our security engineers needs to be notified of right away. That's a page alert. It pages the security engineer. If the security engineer doesn't respond and act that alert within 15 minutes, it pages me. So that one, those are the important, we got to drop now and figure out what's going on alerts. Then we have an email alert. It's less important, but people need to put eyes on it. It goes to the entire security team, not just operations, but everybody in security and compliance gets that alert. And then we have the daily alerts. We've got a daily list of these things happened or these things didn't happen. That comes out every morning on a variety of subjects that we've put into Sumo Logic and said, we want to know about these things. And it could be failed logins. We even have one for new accounts, just so we can track the new customers that we've gotten. So we've set all that up through Sumo just to let us know what's going on. These are just a couple of them, ACL changes. Those are pretty basic. Some of them that are less basic are security group changes. If somebody changes a security group to open to the world, that's going to get a page. We've gotten a lot granular than that. So the security group changes actually are very granular to things that we allow and don't allow. And it depends on whether it's public-facing, non-public facing. We have very strict ingress and egress rules. And if they aren't within that range, then they'll generate a page. All right, Dave, I think you're back up again.
Right. Thank you much, Eric. I think Genesis embodies most of the best practices we were talking about earlier in the presentation. I think as you can see from the outline of the build process and the security procedures they put in place, they democratize security analytics across the various groups. They're looking deeply at the application and cloud stacks. I mean, somewhat by necessity, they live there, but they're fluent there. They invest a lot in the workflow between their analytics and their people, and they've definitely closed the loop with a lot of the upstream security that's not the application layer with some of the downstream monitoring that they do, and they use a lot of effective dashboards to do that. So it's a great case study. So hopefully you got a sense of the sort of big picture of how this evolution in the application build pipeline that companies like Genesis have moved towards, and many people are in the process of moving towards, creates kind of a security landscape, some new challenges and things to think about. Hopefully we've given you some sense of what some of those concrete use cases are and what some of the best practices are in terms of approaching those problems. What we'll do at this point, just given the time of day here, is we still have the room available for another 10 minutes. So what we'll do is bring the formal session to a close, and then the three of us will be over here on my right here, available to have further discussion, take questions, and the like. So we'll start that now, and for the rest of you, enjoy the rest of your day, and thank you for coming to this session.